All right, class, in this lesson we're going to take a look at section 6.6, which is sequences, and we're going to start with the definition of a sequence, which is a list of numbers that follows a rule or pattern. We're going to talk about arithmetic and geometric sequences. Here we're going to first talk about the notation, where we've got A1, A2, A3, A4. It's technically a sub 1. It's a sub. You can actually find a font where you can actually drop a number like this in Word or any Office document. This is sub 1, sub 2, and it's just telling you the order in which something comes. So here we've got a definition for arithmetic sequence. The key here is we have a common difference in our sequence. And for example, here are two arithmetic sequences, and what we'll see is that there's a common difference between them. I like to look at these as a table, where if this is our first term, our second term, our third term, our fourth term, if I turn that sideways and write it as a table, you'll see first term is 3, second term is 7, third term is 11, and so on. What you'll see here is this delta symbol. That means change, so delta is my change. And so the way that I get my delta is I take my second term, 7, subtract 3. My change is 4. And so what that means is if I take 3, add 4, I'll get 7. And if I do it again here, I see 11 minus 7 is equal to 4 also. So if I take 7, add 4, I'll get 11. And it follows that if I take 11 and add 4, I'll get 15. Which means my pattern, my common difference, is 4. So my job is to get the next two terms. I was given the first 4, and the question says write the next 3 terms. I actually missed one. We've got to add 4 here, so 15 plus 4 is going to give me 19. And then 19 plus 4 is going to give me 23, and then for the last one, of course, we would just add 4 more and get 27. Okay, over here we have a second table for this set, where again, delta means change. So if I have this set up, I've got 5 to 3. If I take 3 and subtract 5, you'll see that my change is I'm subtracting 2. And so if I take 5, subtract 2, I get 3. Let's see if it holds true. 3 subtract 2 is 1. 1 subtract 2 is negative 1. And so the pattern is I'm subtracting 2, subtracting 2. So to get the next 3 terms, I take negative 1, subtract 2, I'm going to get negative 3. Negative 3 subtract 2, I'm going to get negative 5. And then if I subtract 2 more, I'm going to get negative 7. So this is how you deal with arithmetic sequences. This is the formula for nth term of an arithmetic sequence. And this formula here will get us there very quickly, where this A1 stands for our first term. This is the number of terms that I actually have, which we're going to actually leave the n. And then this is minus 1. The D stands for our common difference, or delta, also known as that change symbol that I had on the last picture. So what's going to happen here is you're going to be asked to find the 12th term. So in other words, a sub 12, like this, of an arithmetic sequence whose first term, so they're actually going to tell us the first term, this is A1, and whose common difference is 50. So the only thing we don't know is the n, and that's just how many terms we have. So we want to find the 12th term, and that is 2750 plus n minus 1 times my common difference of 50. So all I did was replace my delta, replace my first term, everything else stayed the same. So the key here is that I actually want to find the 12th term. To get the 12th term, all I have to do is put 12 in right here for n. So if I just come through with a calculator, after substituting, it's 2,750 plus 12 minus 1 times 50. So if I go ahead and work this out a little bit, 12 minus 1 is 11. So 11 times 50, and then add 2,750. And if I just type that into a calculator real quick, 50 times 11 plus, so this is 550 plus 2750 gives me 3,300. So this would be my 12th term in this particular sequence. Okay. Now that we're asked to find the 20th term of an arithmetic sequence whose first term is 5 and whose common difference is -2. So here we're asked to find 20th term, so eventually we're going to type in n of 20. But the first term is 5, so that means right here a1 is 5 plus n minus 1. Common difference is -2. Okay, so the only thing that I'm going to do here is I'm going to end up typing in a 20 right there for n, because we want the 20th term. So this is my formula, and so I just write in 5 plus 20 minus 1 times -2. And 20 minus 1 is 19 times -2 plus 5. And then if I just work that out on my calculator, 19 times -2, start there, and that gives me -38. And if I add 5 to that, I'm going to get -33. So this is my 20th term of this particular sequence. Okay, we also can add the first 20 terms of an arithmetic sequence. It's technically called a series when we're actually summing them together. We use this formula here, and what it does is it takes this sequence and it just basically puts plus signs between them. And so our job is to figure out what is the first term and what is the nth term. So it says add the first 20 terms here, and what we can do is take a look at delta, and delta tells us our common difference, because notice we don't have the common difference, but we did this earlier. So how do we go from 3 to 7? We add 4 and add 4, so our series is just adding 4 each time. So our job is to find the first 20 terms. Well, we know the first term is 3, and we want to sum all the way to the 20 terms. So the way that this formula goes is you need to know your first term, that's 3, but we need to know the 20th term. But we don't have the 20th term here. Well, we could keep adding 4 and adding 4 and adding 4 if we'd like. But what we really would like to have is to work our formula from the last problem, which says that this is the 20th term by doing a1 n minus plus n minus 1 times d. And if I want my 20th term, I'm going to have to put a 20 in for n. So this will give us our a of 20. So let's go ahead and plug in what I know. I know my first term is 3. I know my n is going to be 20 because I want the 20th term, minus 1 times my common difference, which was found, is adding 4. Okay. Now again, the reason I want my 20th term is because I'm trying to add all these up and do it as short as possible. And to add it up, this formula says I need my first term and whatever my last term is. And since I'm doing 20 terms, I want the 20th one. Okay, so this is going to be, when I work this out, 20 minus 1 is 19 times 4 plus 3. So 19 times 4 plus 3 gives me 79. So 79 is my 20th term. So up here at the top, what we're supposed to do is plug in everything we know. The n represents how many terms you have. So I've got 20 terms. Then it says A1. I'm sure that's a mess to actually read. I've circled so many things. Sorry. So the n represents the number of terms you have. So this n is number of terms. Okay. A1 stands for the first term, which we know was 3, plus the last term. So this is your last term that you're adding. It's not actually the last term of the sequence because it goes on forever, but the last term that we're adding is the 79. That's the 20th term. And then the whole thing divided by 2. So then you just take your calculator and you divide, or you can just reduce here. We've got 20 divided by 2 is 10. So I'll have to do it over here. So it's really 10 times 3 plus 79, which is 82. So it's really going to be 820. It's going to be our final sum if I was to go through and add 3 plus 7 plus 11 plus 15 plus, and then keep working it all the way out. And if I added all those up, I would get 820 as a total. Okay. So now we're going to take a look at geometric sequences. Geometric sequences have a common ratio versus in the arithmetic sequences we had a difference. So what that means is we have to, instead of doing a subtraction column, we're doing a ratio column. So if I'm going to take this first sequence over here and rewrite it to be, this is my first term, second term, third, fourth, fifth, that's what these stand for, then these are the actual terms themselves in a column. And what I do is I can take the second term, 3, and divide it by the first one. That gives me a ratio of 3. In other words, if I take 1 and times it by 3, I'll get 3. If I follow that, 3 times 3 gives me 9. 9 times 3 gives me 27, and so on. 27 times 3 gives me 81. So my common ratio, R, is equal to 3. Let's take a look at the second table. The second table is going from 1 to 1/2. So if I take 1/2 and divide it by 1, I get 1/2. And if I follow that down, 1/2 times 1/2 gives me a fourth. 1/4 times 1/2 gives me an eighth. And it continues to work out that my ratio here is 1/2. So R equals 1/2. And we'll denote the ratio with an R. It'll make sense in this formula that I'm showing you right now. The nth term, so if I wanted, say, the 100th term of this particular sequence down here, if I wanted the 100th one, what I need to do is have this formula handy right here, which says if I want the 100th term, I would need the first term, which is 1, and times it by my R, which I just figured out was 1/2, to the n. The n is this guy right here, 100 minus 1 power. And then if I type that into my calculator, it's really 1/2 to the 99th power with parentheses, and I would actually figure out what that 100th term was. So let's try one here where it's a little bit more manageable on the 8th term. So if I want the 8th term of a geometric sequence, whose first term is 5, so we were just told what A1 is. This goes right here. And we want the 8th term. The only thing we need to know is R, and we're told R. The R is 3. So it goes right here. So let's set it up. We got 5 times 3 to the 8 minus 1 power. So if I just simplify that one step, it's 5 times 3 to the 7th power. Now please make sure that you don't make this a 15. It's 3 to the 7th first, and then times that by 5. So if I take 3 to the 7th power, I get 2,187, and I need to times that by 5. So if I multiply by 5, boom, I get 10,935. That would be what the first, that would be the 8th term of the geometric sequence. Not the sum, sorry. So this is the actual 8th term, so A8. Okay, so let's try to do another one. If I want to do the 6th term, and we know the first term is 3, so I say 3 is my first term, times my common ratio is -2, so I like to put that in parentheses there so I don't lose my negative. And I want the 6th term, so it's to the 6 minus 1 power, so it's just 3 times -2 to the 5th power, and you throw that into your calculator. If you do -2, you got to be careful. -2 to the 32nd is going to be 32nd. I was trying to give us the answer. To the 5th power is 32, so it's going to be -32 times 3. So 3 times -32 gives me -96. Okay. And so that's what your 6th term would be of that geometric sequence. And that's it for our sequences and series. If you have any questions, ask me through the Ask My Instructor feature of the lab.